So for number 7, you'll see that we have x, our factors are x minus 2 squared, and x minus 3 squared. So our solutions are going to be x equals 0, x equals 2, and x equals positive 3. So 0, 0, 2, 0, 3, 0. If we look at each one, we'll notice this just has an exponent of 1. So this would be an odd cross. The next two both have even exponents. So those are both even bounces. So even bounce, even bounce. And from there, right, we want to determine, is this odd or even? So 1, 2, and 3, right, because it's x minus 2, and then x minus 3, x minus 3. So if I go back, I'm going to recount these 1, 2, 3, 4, and 5 total. So this would be odd because it's degree 5. And the leading coefficient is just a 1. So this would be a positive graph because a is 1. So to graph this, we have 0, 0, 2, 0, and 3, 0. Our right needs to go up because it's positive. Odd opposite, so the left one needs to go down. And in this case, we'll start with the left. So 0 says to cross. So we're going to go ahead and cross, but we got to come back down to 2. At 2, it says we need to bounce. So we're going to go ahead and bounce at 2. So I'm actually going to redraw this to be a little bit better here. So we're going to come up. We're going to go to 2, and we're going to hit that and bounce, right? Kind of do a U-turn here. Come back up, but I got to quickly go up and come back down because I got to get to 3. So we're going to quickly go up and come back down to 3. But again, at 3, we have to bounce, right? So we're going to take that and kind of create a little U here, and there's our graph. Okay, so at 0, we had to cross through, 2, we had to bounce, and 3, we had to bounce. Okay, and then from there, again, these don't have to be anything specific, kind of the little like camel humps, looking things. Those, you can draw them as high as you want, or you can go all the way up here somewhere and come back down. I don't really care. It doesn't really matter for what we're doing. Okay, but that idea of when to cross versus when to bounce is what's important. Okay, so as long as you get those correctly, I don't care how high up those go, how low you want them to go. That's all kind of a personal preference. Because again, this is a sketch, right? If we wanted to be real specific and figure out that, oh, that point needs to come all the way up to here, right? Then we'd build a table and figure it out. But in this case, we don't need to. So that's number 7. Hopefully you guys tried that on your own and got pretty close. Okay, and it'll get better over time. And now the last part is writing a function given a particular graph. So we're kind of basically do the same thing except backwards. So instead of having an equation and kind of write some stuff out to get our graph, we're now given a graph and going to kind of build it back to be into the equation. And our directions here, kind of an important thing to note, is it does say assume that the leading coefficient is either 1 or negative 1, which makes this a little bit easier. We really just have to determine, what direction is it pointing, up or down. Okay, so for number 8, we're going to start with that part. We'll notice our right arrow is pointing down, which means A must be negative. And in this case, we're going to say, let it be negative 1. Okay, so our right arrow is pointing down, A has to be negative 1. Then we're going to go and look for all of our x-intercepts. So in this case, we have one at -2, 0. We have one at 1, 0. And we have another one at 3, 0. The rest of that graph, right, doesn't really matter for what we're doing. And so since we have those solutions, right, we have solutions of x having to be -2, x having to be 1, and x having to be 3, the question we now have to ask ourselves are what were the factors that would have given us those solutions? Well, for -2, that would have been x plus 2. For x equals 1, that would be x minus 1. And for 3, that would be x minus 3. In our last part, before we put this all together, is we want to see what was happening at those points. So in this case, for -2, there was a bounce here, right? We have that kind of U-turn effect happening. So that should be an even. So we're going to go ahead and tack on a square there. At 1, we crossed through, so that should be odd. And when it's odd, we're just going to go ahead and leave it as a 1. Okay, we're not going to worry about making the 3 or 5 or 7. We're just going to make it easy on ourselves and just do a 1. And at 3, we'll notice another cross. So again, another odd. So again, just 1, which means we really don't need those even to begin with. And so lastly, for our final answer here, our function f of x has to equal our a, so -1, and then we can write our factors, x plus 2 squared times x minus 1 times x minus 3. And that is it. Okay, so it's taking that information from the graph and converting that into an equation. So it's all kind of that same stuff we just did, just kind of the opposite direction from what we just worked on. I'm trying to shrink this. Maybe it won't let me do that. We'll find out in a second. Sorry. Yeah, that'll work. We'll do it that way. Okay, so number 9, if you want to try it on your own, go right ahead and pause the video and then see if maybe you can get this on your own. If you're still kind of not sure, then you can just let it play. I'll wait like 3 seconds and then start. But yeah, if you want to try it on your own, go ahead and pause and then check back after you're done and see how you did. So number 9, first thing we want to notice is our right arrow is pointing up, which means A needs to be a positive 1. Then we're going to go through and look for all of our x-intercepts. So -3, we're at 0, 1, and 2. So we have x equals, or solutions, sorry, I should label those. It's always good to label our work so that we know what we're talking about. X has to equal -3, x has to equal 0, x has to equal 1, x has to equal 2. So what factors could have led us to those? For the first one, this would be x plus 3. For the second one, when would x need to just be a 0? Well, that's when there's just an x. X is positive 1 would be x minus 1, and x equals 2 would be x minus 2. Go back and look for crossing and bouncing. So we'll see at -3 there's a bounce. So that's an even, so a squared. At 0, it crosses, right? It goes from down here below to up above, so it does cross. So we're going to leave that as just a 1. At 1, it crosses again, so we'll leave that as a 1. And at 2, it also crosses. So that's a 1. And so when you have a problem, the only difference with this one that we're going to encounter is the fact that there's just a plain x here. So when we write our function, we typically want that to come first. Okay, so we're going to say f of x equals our a, so 1. All right, if we go back to the top, we said a was 1. So a is going to be 1. Then we're going to put the x that's by itself, and then we can just go in order from there, right? Follow our kind of factors that we wrote out. X plus 3 squared, x minus 1, x minus 2. Is it wrong if the x is kind of stuck in the middle somewhere? No, but it's just not as clear, right? If we do this, x plus 3 squared, x minus 1, it almost kind of starts to look like a multiplication sign. And that's not really what we want, right? We want it to be treated like an x, like a variable. And so that's why we typically don't do that, right? It's not wrong per se, but it's just a lot better to put it out in front, okay? So that's it. That is 3.3. Hopefully you guys understood at least most of that, okay? If you still have questions, you can always come see me. I'll be back on campus on Tuesday, so you can come by during lunch and ask any questions you have. And as a reminder, you have a quiz coming up on Wednesday for 3.1 and 3.2. So if you happen to watch all the way through this and finished these videos, go ahead and send me a message on Remind that says, hello, I like pineapple. Even if you don't like pineapple, just tell me that you do. That way I know that that's who actually finished all the videos. Okay, so if you got any questions, let me know. Send me a message on Remind or come by my room at lunchtime.